Good morning, good afternoon, I should say. Good afternoon, everybody. And thank you for joining us. My name is Wendy, and for those of you who don't know me, I am in the Charleston area doing business development. So it's kind of fun to join these from time to time. So thank you for joining us. The class that we're going to be doing today is going to be on electrical, and it's kind of taken from our 6-series webinars, our 6-series webinar of the major systems in a home. So this is the first one. So we'll be each week we'll be covering a different one, but we're going to be starting off with the electrical. So how it works is that it's basically 30 minutes. Rael will be presenting, and we're going to go for about 20 minutes. And then after that point, he'll be open for any questions that you might have. So be sure if you have questions to put them into the chat box, and I'll be taking a look at that, and then we will open that conversation up right after about 20 minutes or so to really keep it at that 30-minute timeline. So with that, Rael, I'm going to hand it off to you.
Okay, thanks, Wendy. Well, yeah, welcome everybody. A little bit of my background is I've been in real estate business since the 1970s, and went through as a contractor, owned a lot of rental property, learned how houses actually function and work. And I've actually done for our company almost 4,000 inspections over the years that I've been with HomePro, which has been about 18 years now. So we'll go ahead and share our screen here and look at our electrical. And here we go. Okay, so here we are. And let's jump right into it, shall we? So, being that we are beings that need electricity for our lights and for our heating sometimes, and for all these wonderful things that we need to run our computers, etc. There are several factors that fall into our electrical section. And the webinar that's actually electrical, as Wendy mentioned, is just a small portion of an actual CE class that we do that is that falls under the anatomy of a house kind of heading, which is a 3-hour class in the Atlanta area, in Georgia, and a 2-hour class in South Carolina. So we're going to go through all of these different we're all going to do the large overall look at what we need to do here. So let's look at it. So let's start right at the beginning, where we're looking at the actual supply of electricity from the streets and to the home. We see here that there are certain distances or clearances that we need to have between the actual wire that comes in from the pole to the home. And you can see here on the top picture that over the roadway, we need to have a clearance of 18 feet, over the driveway, 12 feet, and over a flat section of the roof schematic that you see on the right side here, 8 to 10 feet there. And then if you're attaching to the home at the top of the home, an 18-inch mast that's there. We'll see a photo of that in just a moment. So 8 foot of clearance if the roof is not used as a walking surface, and 10-foot clearance otherwise. And then we come on down here below and we see that it's 18 feet above a swimming pool, 3 feet above the top of the peak of the roof, walkway again 10 feet, 18 feet above the driveway. Now, the fact is that most new construction now, we're seeing all of the utility electricity function coming to the home underground. No longer are we seeing the poles out there in the street and the wire coming in. And certainly I think that's a great improvement that we've seen, because now trees don't fall onto the wires and destroy it and knock out the whole neighborhood when there's a storm. So underground electrical supply is great. Here we're looking at what we call the service drop. And the service drop is actually that little mast that I was talking about that on older homes. And when I'm speaking about older homes, something with, beyond 20 years, 15, 20 years ago, and we see that we have this mast, and it's really important. You see in the schematic here, they have this area called the drip loop. And that's actually the function of not allowing water from the rain to run down the water line and cause a shortage in the conductors that are running through here. So this is the way that it's done on the exterior. They can also be attached underneath the home at the soffit, which is the overhang. And you see in this picture was taken from one of our inspections where there is no drip loop. It really needs to be a pretty good drop in. And as you can see in this picture, it's almost like the shape of a V. And this one doesn't have enough of a drop on it. So the connectors are not really protected all that well. And here's another one where it's actually would have been okay if it had been going down instead of over the top. But again, we don't have that correctly installed. So we would point that out in the actual report and make sure that that is actually corrected, which is a minor fix right there. So we see also about, we're looking at a lot of current that's coming in from the street to the home. And way back in the early days in the 50s, if you had a 100 amp electrical panel or service, that was sufficient. But today, with all of our big screen TVs and our computers in each room and electronics, never mind the coffee maker, the toaster, the dishwasher, and the lights, we've been needing more and more electricity. And it kind of seems strange because I'm thinking about back to the 50s and 60s where the family would gather around the one big TV in the home, like a big console, a piece of furniture, if you please. And they would watch a show together. And now we tend to be kind of getting away from everybody else and we do our own thing. We want to watch, somebody wants to watch one program and somebody else wants to watch a different program. So now we've got 2 or 3 or even more TVs running at the same time, as well as being online and using up that capacity of electricity there. So when we talk about bringing in the wire from the street, and we see about how it attaches to the home. And prior to the times when we were using underground utilities, there was a connection to the home and it could be right near a window. So the wires needed to be at least 3 feet away from the sides and the bottom and front of the windows, whether they're operable or not, the windows that is. It's just amazing. People, kids, they wanted to stick their hands out to see, could they touch that stuff? And of course, it was a really dangerous situation. You can see here from one of the pictures that was taken, not only is there no drip loop, but it is so close that literally can reach out of the window and touch that electrical wiring, which is a hazardous situation. Main disconnects at the meter. So we're looking always for the main disconnect, and there would always be a photograph of the disconnect, whether it be in the meter, next to the meter, or in the actual electrical panel itself. In our reports, there's always going to be a photograph of where the main disconnect is. So in an emergency, if it would need to be shut off everything in the whole house, that's where we'd have to go to. And it's a good idea to have a photograph of it so that the buyers know when they move into the home where that main disconnect switch is. And here you see how it is in the electrical panel itself at the very top here. All right. Okay, so common problem with service sizes is sometimes they're too small, but it's not really a safety concern there. You either have enough current or you don't. So 100 amp services are common and acceptable for most homes. And as we get more stuff, we need more power. So we see now that pretty much 150 amps for condos and 200 amps in single family homes is not uncommon, as well as multiples of that same thing. So what's happening recently is what I've been seeing is that when folks are having new homes built, and say it's a multi-level, so there's a full basement that's unfinished, so perhaps to keep the price point lower. So they might stud the basement out with the 2x4s and walls there, but nothing else is done to it. Or sometimes it's just the actual cement poured concrete walls that are in place and nothing at all has been done. And so we would have power coming to the home for the second and third floors. That would be 200 amps. And if somebody decided they wanted to go ahead and finish off their basement area at some point in time, then an extra panel would have to be installed to carry more power for that area. And at that point, you might add what they call a sub panel, which would be again 150 amps or another 200 amps, depending on what was required there. So, if you might have had your HVAC system sitting down in the basement, which is actually for the floors above, so the main level and the bedroom areas above that, they would have to add a separate HVAC system for the basement area, which would be a lot smaller than what it would be for the two levels above, but nevertheless would require power. And so we're looking at, approximately spending $6,000 to $8,000 to $10,000 on an HVAC system with ductwork, etc., for just the basement area, plus the electrical panels. You can see how you might very quickly be dealing with $25,000 or more, depending on how intricate the finishing off of the basement might be. So let's look at the different types of wiring that were there. We see right here the old style knob and tube wiring, which is actually aluminum wiring here. You can bottom right hand side, we'll see that knob. It's actually a round ceramic type knob, and it had the wire running through there, and it had an asbestos covering. And whenever we would see it, whenever we would see it, we would recommend really removing it. We do test to make sure that it is not active. This is basically now a situation where the coverings on the wire has probably dried out and fallen off. And when it's exposed to insulation, it's a possible fire hazard. So we want to make sure that that is not active. And just as I mentioned to the buyers, like, maybe you want to go ahead and have that taken out prior to adding any more insulation in an older home, then it would be totally buried there. But at the point that the buyer becomes the seller, it might become an issue on the sales side of it, however many years down the line the home was sold. We're going right above that to pre-1965. We had the black and the white, the positive and the neutral, older style cable. So it's two-prong wiring is what I call it. And you can see here it has actually a cloth outer sheathing to it. And that's what was done. And you would see those two conductor electrical outlets, the two-prong outlets that we see in the picture in just a moment. So what we see here on the left bottom side is the modern cable. It has a plastic sheathing on it, and it has two conductors, the positive and the neutral, as well as the ground wire, right? And so since 1960s, this has been what we see for construction. Right above it, we have a four-prong. So we see a red, which is hot, another black, which is hot, ground wire, and a white neutral. It has a plastic covering, and these were used for 240-volt circuits. Also after the 1960s. I'm seeing a lot of this, and so basically the 220 or the 240-volt circuits, 220 connectors are for electrical dryers. And as we see, gas dryers are kind of either not being manufactured anymore or certainly not being installed. We have electrical dryers, and this is what the 220 line was for. We're also seeing them installed in new construction in the garage areas for electrical vehicles to be recharged. So that's the story on the wiring and connectors in there. So when we look on the left here, we see those ungrounded outlets, which would be that original wiring with only a black and a white wire. And on the right side, we see the grounded outlet. And what we're looking at here is the one that had the extra leg, which was the grounding wire. Alrighty, so this is what we use to test it. It was so often that when we would see a renovated home that was up for sale, we'd go in and we'd do the testing of the electrical outlets as part of our inspection. We would see that even though there was a 3 opening, like here on the grounded outlet, even though it was showing the grounded outlet, when we used the tester, it would show up as an open ground. So if you look carefully at these testers, on the left here, we see it says in the middle, you see like a yellow light there in the center, which shows us as an open ground. But what that means is that there's been no ground wire connected. And what's been required in construction for some time now is in our bathrooms and in kitchens, anywhere near a water source within 3 feet, we have to have a grounded outlet, GFCI, ground fault circuit interrupter outlet. So that little red button that we see here is what we as inspectors use to create a differential in the amount of power going to the electrical outlet. And if there's no ground there, then it would show us with that little yellow light in the middle that there's an open ground. And we would need to get an electrical contractor to come in and go ahead and fix that, add a grounding to the actual outlet. So lots of renovations were being done. GFCIs were being installed. 3-prong outlets were being installed throughout the home, simply because most of our appliances that we're going to plug in today are going to be 3-prong outlets. So your Keurig machine, your toasters, they're all going to have 3-prong outlets to plug in. But also, besides the ground, it would show us that it's an open neutral. So if the white wire wasn't connected properly, hot and cold, hot and ground would be reversed. So it would show us a red and a yellow. So get a lot of information out of these little tools right here. Overcurrent protection, fancy name for fuses or breakers. So what we're looking at here is early on times we had fuses on these older homes. Modern times now we have breakers. So what did the fuse do? Well, the fuse did exactly what a breaker does. In the case of a breaker, if there's an uptick in the power, there's an overload on that particular circuit, the breaker trips and has to be reset. With the case of a fuse, if there was an overload on that circuit, the fuse would blow. When I had rental property, it used to really concern me about how the folks would come in and they would take a penny, take a screw, unscrew those fuses, put a penny in there behind the fuse and screw the fuse back in. What that basically did was it created a gap between the power overload into the fuse, which stopped it from blowing. What actually happens is when electricity travels, it creates heat. And when the heat gets extensive, it blows the fuse or trips the breaker. Well, in the case of the penny in there, there would be a fire in the actual panel before the fuse would be able to trip. So, I would always be concerned. I would go by my rental properties on a regular basis and pull out the fuses, make sure that there was no obstruction on the inside there to stop it from tripping the fuse. So when we see those fuses there, we would have a condition in the inspection that says fuse style electrical panel is old or obsolete equipment. While the panel may still be in good and serviceable condition, it's recommended that all conditions outlined in the report be repaired or evaluated by a qualified electrician. A short-term recommendation: when insurance is not an issue and the panel and wiring is serviceable, GFI outlets or breakers can be provided as an interim safety improvement before replacing the system. And the cost of a GFI outlet is about $100 a piece. And one GFI does protect one entire circuit. The long-term recommendation would be replace the fuse style wiring and during renovation or remodeling projects. And then we're getting into some costs there. Okay, so here we are looking at a close-up of our electrical panel with fuses. And what's interesting about this one is you can see the different colors, right? So this red one on top is a 20 amp fuse. And the one down here is a 15 amp fuse. And you see the blue ones are all 15 amp fuses right here. So 15 amps would be pretty much for just a normal electrical outlets or a light fixtures in a room. The 20 amp would be for something larger, perhaps like a small air conditioner unit. So that's there. But what's also important to look at on the left-hand side of this, where my arrow is here on the left-hand side of the second fuse, are 2 wires being attached to the screw on that particular fuse. And that's what we call a double tap. We'll see another picture of it in just a moment. But that causes an overload on the circuit. So we've got somebody had done some remodeling or added some extra electrical stuff in the home, and there was no room in the panel in this panel to add the wire that went to it. And so we've gone ahead now and tapped into this top fuse, and that's not a good thing to do. It needs to be removed from that and created when renovation is done with a breaker to separate the two wires from each other. So here we are looking at the inside. So we always want to take off the cover of the panel, and that's really important so that we can see inside the panel and that we can tell our clients about what it looks like inside there. What we needed here, and this would be in the report as well, we can see some writing on the side here of the panel, but in this space where it was removed, there was actually a contents page where each fuse was labeled, or each breaker was labeled, so that you could look at that and tell what it was attached to. So in case there was some repair that needed to be done on a particular item, you could shut off the breaker for that item, have it repaired and replaced, and then go on back and reset the breaker, and everything would be hot and wired again. So you see, as I just mentioned, the electrical cover is always removed, and you see here that it's really kind of full of wires. It's kind of overloaded, it's crowded. We see that little yellow sticker right here where there's been a double tap. And you can see also, if you look carefully, there are actually two little switches on each of these breakers. And it's a double breaker. And this is the great advantage that's happened over the years, where instead of having double taps on one single breaker, they've now made a breaker that would take two wires individually, and they would be able to trip individually as well. Okay, so we looked at this again, the double tap right there. And we see the fuses here in the panel, and the two red arrows are pointing to fuses that are actually blown and no longer active. So this is what the double tap circuit breaker looks like, where the two wires are coming in to that same breaker. So changes to components in our home are ongoing with newer or upgraded safety and convenience devices. Example, of course, is the grounding of electrical systems and the introduction of GFCI, which is ground fault circuit interrupter, and AFCI, which are arc fault circuit interrupter outlets, as in the most common in recent history. So arc faults have been around for a good while now, but what is an arc? So if you think about plugging in any kind of appliance and you see a spark as you plug it in, that's called arcing, and that's the issue that we need. And so I'll make a comment about how I know that everybody always takes care of vacuuming behind their beds. Well, we always pull the bed away from the wall and go in there and vacuum the lint that's in there in the back, and keep it nice and clean, because if there was an arcing that happened, that would be combustible material behind there. But that's just kind of a hint of where it all came from. It's that spark that comes from an arcing that is a possible fire hazard. So we're looking at right here where we are looking at the GFCI breaker. Back in '71, it was on the exterior homes and swimming pool equipment, and then it later became a requirement in garages and kitchens and bathrooms. And this is what an arc fault circuit interrupter looks like. So when you talk about the arc fault breakers, these are always going to be in the electrical panel, whereas the GFCIs, they can be reset at the point of contact right there in the bathrooms and the kitchens, or actually in the electrical panel as well. All right, looking at just a weather cover, something simple like that, taken on an inspection. We're exposed to rain out here, so we should have a plastic cover over on the switch outside. If any of you remember, some of the older homes used to have a light fixture in the bathrooms in the hallway, and in the light fixture there was a two-prong electrical outlet for folks to plug in a hairdryer or electric shaver, and the medicine cabinet, when you open it up, was just a single, with a mirror on the front. You could just open up that single door. In the bottom of that little medicine cabinet was a little strip, at maybe like 4 or 5 inches wide by about a 1/4 inch deep. And what folks used to do with that was they would actually take, in the days when they had what they call a safety razor for shaving, they would take the blades out and drop it down into the medicine cabinet slot, and it would actually be collected in the wall. And when you do a renovation, you would find like hundreds of blades in the wall back there. It was kind of an interesting thing to see. But in this particular case, I'm looking at a renovation that was done. And they've got a nice new medicine cabinet there, but they don't have an electrical outlet, which is a requirement by code to have not only electrical outlet, but a GFCI, a ground fault circuit interrupter type red and black unit that's installed in the bathroom here. So when I see that this was not installed, then it makes us as inspectors, we think, well, maybe somebody didn't permit this particular item. And that's important because if for insurance purposes, if folks find out that there was no permit taken, electrical fire happens, and there might be an issue with trying to get the insurance to cover it. Same thing here where the basement was finished and they forgot to put the electrical outlets in there. This is not the way to do it. We want a proper GFI outlet located here for that refrigerator. And then this one here, and no, there was nothing underneath the cabinets. I looked, so it was just forgotten. And at this point, it's going to be a pretty expensive remodel to get them in there. Limitations. So just quickly to tell you about limitations, when you see the reports that come from inspector, there's going to be a recommendation section in our report, which is going to tell us exactly what we're looking at, so we can show the client, for instance, that the burners on the gas cooktop were working, on the electrical surface unit, they were working. And then if something was not working, it would be under the recommendation section. Most folks tend to go to like the roundup at the very end and look at that, say, oh, okay, there's nothing much here. But what we really need to do is look at what I consider the most important part of an inspection report, which is limitations. And limitations are the things that we could not get to see and could not get to test, things that we could not get to operate. And in this particular case, we've got a whole big shelving unit here, and the electrical panel is right behind the shelving unit. We would request that the shelving unit be moved out of the way so that we could get to that panel. All right, and here we see some cabinets were installed, but nobody thought about having access to the electrical panel. Openings in the panel need to be filled. We can't have openings like that. All kinds of critters and bees and all kinds of stuff get in there. We want to have that to be filled in. And all of these little plugs can be purchased at the Home Fix-It store. Here's another one, little opening there. Okay. And then tons of stuff like this is regular stuff that we find where opening on the top of electrical junction boxes need to have covers on them. On the bottom left-hand corner, we're looking at flying splices just open and taped up. Again, fire hazards. We need to have them installed in these type of junction boxes with covers. Just quickly about a few of the electrical panels that are defective. Federal Pacific was manufactured from the 50s until the 90s. And shown that the breakers will be defective and they won't properly trip. Again, fire hazard there. Zinsco was another one. The electricity burned the wires until they're melted. And Sylvania as well. They're also uninsurable. The IT Bulldogs Pushmatic, again, another one of these defective type panels that are out there. When we see them, we of course will always put them into the report. Fact is that a lot of the disclosures now to the insurance companies when they're doing their workup for the cost of the insurance on the home, the questions are all kinds of things about shingles and wiring, et cetera, plumbing, what kind of equipment is actually in the house. So we look at a couple of pictures here. That's a Zinsco up here, and we're looking at the Sylvania, Federal Pacific. So they're out there. And the last thing is grounding. So it used to be that you see here water pipe grounding back in the day when we had copper and galvanized steel for water pipes. Then we could do our grounding there, or else we had a spike in the ground where you see it coming in here and it was clamped in there to get our grounding. Most new construction these days, we have what we call a UFER, where we have wiring attached. It actually goes into the foundation when it's being poured. And we see it here connected. We're always looking for a grounding. We're always going to photograph it and actually put it into the report so folks know where it is. And so, yeah, this is what happens when we don't take care of our electrical stuff, bring it up to date, keep it safe. And we are at the end of our webinar. So let's just go ahead and see if we have any questions.
I don't think I see any questions in the chat, but one thing that I did want to, just from me, as far as a question that we've had in the past when we've talked about the electrical system in a home, is the double tapping. Raelle and I did a CE class for an office, and that was one topic of conversation that came up, and it was amazing to us how many different opinions there were. And Raelle kind of set them straight. So the question, that we kept getting is, well, this person said it's okay if, or if this situation was that. And so bottom line, is there ever an instance when a double tap is okay?
No, it's never okay. We always want to
Okay.
have those wires separated. We don't want an overload of heat going through any of the wires. Folks, you got to imagine that, when we saw those pictures of the 15 amp breakers or the 15 amp fuses, that carries the wire size to that breaker. We also don't want to have a 15 amp capacity wire going to a 20 amp breaker, because the heat on that 15 amp wire will flame before it breaks the connection. And so that is, again, a hazardous situation. You never
I
want
love to
double
talk about
tap.
that because it seemed to be such a hot topic when we covered it. So I just wanted to make sure that we kind of clarified that. So thank you everyone for joining us. This is the first, as we mentioned, that new year, we're starting off fresh. This is the first of our 6-part series. Next week, so they're going to be every Wednesday from 12 to 12:30. Next week's is going to be on plumbing, and then we have HVAC following that next week. So all you need to do is go onto our home-probe.com website, click on education, and you'll see real estate education, and register. They're free. We would love to have you come back and bring your questions, because we really want to use this tool as a way to help you just make your life easier and help your clients. So I think with that, we're off to the rest of our day. Thank you, everybody. We'll see you next week.
Bye.